Hey guys, so I just solved this problem and I thought, yeah, I don't know, I should make a video. This problem is solved by digit DP. So yeah, I just thought that, yeah, let's make a video for digit DP. And yeah, here I am discussing it with you guys. Anyways, so let's get started. So we are given two numeric strings, num1 and num2, and two integers, maxsum and minsum. And the x should lie between the number x would be good if it lies between num1 and num2, and the sum of digit of x lies between maxsum and minsum, right? And we have to return it modulo 10 to the power 9 plus 7, the number of good returns, the good integers, I mean. And yeah, so let's just go to the constraints, and the constraints are pretty high. The num1 and num2 are less than equal to 10 to the power 22, and the min sum and max sum is less than equal to 400, right? Okay, then. So usually when we solve digit DP problems, so by the name it suggests that it can be solved by, it involves some operation on digits. You can go through one blog, I think. One second. CP code forces digit DP blog, I think. Digit DP. Here it is. Yeah. They have written a beautiful blog, so you can go through it. But yeah, here I am just summarizing it by doing this problem. So yeah, you can just follow it also. Anyways, so when we are looking for, digit DP problems, they usually involve some operation on digits, right? And by constraints, you can also see that the constraints are pretty high. So you can't go through, every number. You can't brute force the answer, right? So yeah, this rules out any brute force solution. Uh, and usually these type of problems are also solved by combinatorics, but usually this if we are solving this problem involving digit DP for ranges, then this usually involves digit DP, right? If we are solving for some digits, right? Anyways, so let's just get to the whiteboard and we are gonna write the conditions, right? So I was gonna make it n, why did it make it m? Anyways, num1 is less than equal to, yeah, num2, and yeah, this is the first condition, and when sum is, and one second, yeah, max sum, right? Max sum. Okay. So, what should I discuss with you first? Yeah. So, usually in these type of problems, we solve it for ranges, right? So, I'm gonna, solve it for the number of x which lie between num1. Let's just say it's answer 1, and I'm gonna solve it for uh, 1 and num2, right? And then I'm gonna solve it, then I'm gonna check that if num1 itself satisfies this condition or not, right? Then we can say that if it satisfies, then we are gonna call it answer 3. Answer 3. One second. And we are gonna set it to 1 if it satisfies, or no if it 0 if it doesn't. Anyways, so the final answer would be answer 2 minus answer 1 plus answer 3, right? Okay, then. Okay. Now we are gonna, discuss how we are gonna get to the actual answer for, let's just say, for num1, right? So we are gonna traverse through the digits first. We are gonna check if the digit I, we are gonna check the conditions for some conditions for each digit, right? So I'm gonna write a recursive solution. I'm gonna explain a recursive solution. So let's just say it's rec int I. I'm gonna just writing the pseudocode. I'm gonna explain it after it. And flag, and it is int current sum, right? So the I is the ith digit, and the ith digit, and we are gonna compare, we are making a number through this recursion, right? We are just let me tell you that we are going through some number like this. For example, the number was, we are traversing through a number through the recursion, right? And the number was, 3, 4, 5, 6, 7, right? So we are gonna traverse through it, 3, 4, 5. We are gonna traverse through every digit, every, digit. So the I denotes the ith digit of this number, right? This whole number. So, and the flag denotes, let me just tell you about this flag. This is the most important thing. So, in digit DP problems, whenever we are checking for a condition, right, for these kind of condition, we need a, flag value, right? So, what a flag value does, for example, we are checking. So, for example, we are, traversing through the numbers, right? So, for example, the previous digit of the number we took was 3, right? And then I'm checking what what all are the digits that I can take for this position, right? This position. So all the numbers less than or equal to 4, I can take here, right? But not greater than 4, because that would mean that it will become 5, and this will become greater than, you know, this number, the number num. We are checking for num1, right? Here, let's just suppose we are checking for this answer 1, right? So it will become, greater than num1, right? If we put 5 here, okay? So we can't do that. So the flag will ensure that if the previous digit was, equal to, let's just say that it is num1 and it is num x, right? We are gonna call it num x. I don't know. Okay. Anyways, so it's gonna check, this flag checks if num1 I minus 1 was equal to digit x, sorry, num x I minus 1, right? If it is, then this flag will be 1. So we are gonna set the limit to, num1 I. Okay. If it is not, then we can set this, for example, if it would have been, 2, right? Then we could have set it to 9. Okay. So, yeah. So this flag ensures that. And the curse sum, this is pretty self-explanatory, I think. So this suggests the number of the sum of digits till, this digit number, ith digit number, right? So yeah, I think I have explained the, recursive solution we are gonna aim to, right? Personally speaking, while solving digit DP or any sort of DP, I like to follow, recursive approach, because it makes life easy. It is quite, I think it's quite easy to imagine, a recursive approach instead of iterative approach. I myself find it, quite hard to go with the, iterative approach. So yeah, I have coded it with recursive approach. As you can see, the code is quite messy, but yeah, anyways, bear with me. It's been a while since I have coded on, LeetCode. I've solved any problem. But yeah, let's just go through the code. Okay. So we have what we have here is I'm initializing an int I, and I'm initializing a DP array. So I've explained the DP state here as well. So I'm gonna initialize this array by -1, and I'm calculating the difference between the sizes of num2 and num1. So if there is any, for example, if the num2 is 100 and the num2 is 100 and num1 is 10, then we'll have to add 0 to num1, right? So I'm doing that here, and I'm adding number of digits to num1, and I'm assigning mi and ma to minsum minsum to mi and maxsum to ma in these global variables so that I can access them globally. And yeah, and I'm also assigning num2 dot size to n, the size of num2, so that I can also access it globally. And then I'm calculating the answer for num1, right? So you can see that I'm passing the flag value to 1 here, right? So if you see that, for example, the num1, if the num1 is, for example, we take it num1 to 213, right? So I'll have to set the limit to uh, 2 here, right? I can't take the limit to 9. So I'll have to set the flag value to 1 if I'm going to this recursive function, right? So let me just go to the recursive function and tell you what's happening there. So if I is equal to, n, the digit index is equal to n, then it suggests that we have we have gone through all those digits. Okay, and then we are gonna check if the current sum is greater than equal to mi, and the current sum is less than equal to, if it is greater than equal to mi and it is less than equal to ma, then we are gonna return 1, because then the digit has satisfied the this condition, right? And if it is not, then we are gonna return 0. And if we are gonna check that if we have cached any value in this DP array, right? If we have cached any value, then we are gonna return this value. We are gonna check if it is not equal to 1, -1, right? And here I'm setting the limit, and I'm checking that if flag is equal to 1. If it is, then I'm gonna set the limit to the ith digit of the num1, right? This is the num1 we are passing, yeah, in the recursive function. So yeah, we can access it from here. And then I'm gonna traverse through every digit from 0 to that limit, and I'm gonna check if the number IND, calling it IND for some reason. Uh, so yeah, if it is equal to limit, then we are gonna set the flag to 0. If the flag is 0, sorry, if the flag is 0, then we'll pass it, we'll add the answer, and the recursive call would go to the next digit, and the flag value will be 1, because the flag value previously was 0 also, right? So it doesn't matter what digit we choose next also, right? And I'm gonna add the sum IND to the sum, right? And if the flag value was 1, right, then if it is the if the IND is equal to the ith digit of num1, right, then I'll have to pass flag value 1, and I'm gonna similarly add answer retrieved from that recursive function. And then I'm gonna add the, if this is not the case, if it is not equal to limit, then I can call this recursive function and set the flag value to 0, and add curse the sum to the IND, like we did with these two, right? And then after all these operations, all the answer we have gotten, I'm gonna add, I'm gonna cache the value we have got for this state in the DP array, and I'm gonna return it, right? So yeah, we have calculated the answer for num1, and then I'm gonna reinitialize this DP with -1 because we are gonna solve it for num2. So we'll be needing that. We don't need previously cached value for some another uh, problem, right? For another value, right? So we erase it here, and we calculate for num2, and I subtract the answer by answer 1, right? We subtract the answer, and then I add 10 to power 9 plus 7 here. And why am I adding it? Because in C++ or C, we actually it it doesn't understand what the negative modulo means actually. It isn't defined. This is what I have read. I don't know. You can read it, but I don't know the particular explanation, the correct explanation. Sorry, but what we do usually, we make it positive by adding the modulo m. So why it doesn't change the answer? Let's just say that we had answer modulo m, right? This was our previous answer. If I add answer plus m modulo m, then we know that m modulo m is actually 0, right? So it doesn't change, the resultant answer, but it does make it positive, right? The current modulo answer that we have gotten, right? So I add 10 to power 9 plus 7 to make it positive, and then I check if num1 is actually, we had to check answer 3, right? If num1 is if num1 in particular satisfies this condition or not, right? This condition, because we have subtracted the answer for num2, and the answer of num1 from num2, right? So the answer for num1 also got subtracted. So we are solving it for that. And the question you might be thinking that why didn't you, subtracted num1 from here, right? You could have used stoi from C++ and subtracted it, and then calculated for this range num1 -1. But I did, but I just forgot that the constraints are pretty high, so STOI can't convert it for this much digit. So I calculated it for num1, uh, and if the sum of all the values, sum of all the digits of num1 was satisfying this, then we will return 1, else we will return 0. So yeah, this was pretty much it. I don't know, I have written a bad code, but yeah, what can you do? Anyways, yeah, peace out guys, bye. And yeah, go through that uh, blog, I think. Yeah, it's pretty interesting. So yeah, bye.